Welcome everybody to the Cloud Complexity Management webinar. We are so happy to have everyone here, and I'm Ben Newton from Sumo Logic, your host. And we are very excited about our guest today who's going to be talking through this. David has done a lot of things in his careers. Right now he is the Chief Cloud Strategy Officer at Deloitte, and he was just named the #1 cloud influencer by Apollo Research. He's a thought leader, an executive consultant, author, and speaker, and I think for most of you, most importantly, he's actually done the job. He's been a CTO 5 times, and he's been a CEO 2 times in the last 25 years, so he knows his stuff. So without any further ado, let me hand it over to you, David.
Well, thank you very much, Ben. I'm looking forward to really going through this topic because this is something that's near and dear to my heart, the ability to look at enterprises as they move into 2019, 2020, and what realistically are going to be the pain points that they're dealing with. And if you think about this last 10 years, we spent a lot of time in relocating our existing workloads into the cloud. And we're leveraging different architectures, including hybrid and multi-cloud architectures to make this happen. And people are kind of reaching the 1,000 workload, 1,000 data store point in migrating this information and migrating these workloads into the cloud. And we're seeing a couple of things arise as these things start moving in place, namely the fact that it's typically going to be dealing with much more complexity. We're dealing with more service points, more applications, more data stores. And also we have to make these things work and play well with our existing technology. So if you look at the stats here, large enterprises are focused on delivering hybrid and multi-cloud model, and that typically is what's going on right now. And so why we were talking about the planning of these systems, say for the last 5 years or so, now we're deep into the implementation and migration of this, of our assets, our IT assets into the cloud. So 85% of enterprises are evaluating or using public cloud today. 87% have taken steps forward to a hybrid cloud strategy, basically looked at hybrid cloud and making this decision as to where they're looking to go, and they're going in 2 directions, mix of public and private cloud, mix of legacy and public cloud, and then also leveraging multi-cloud. 94% plan on using multi-cloud providers based on business requirements, and 90% will use hybrid infrastructure services by 2020. So basically, most enterprises are all in on cloud computing, and there's a good reason for that. We've kind of focused our R&D efforts and the cloud services that are being stood up these days. We're looking at this as kind of the enabler of most of the net new systems. We're typically not building those on-premise anymore. And also the cost of migrations are coming down, and the cost of cloud ops for actually running things in cloud is typically going to be lower. But there's a price to be paid for the benefits being that we're able to do things cheaper, better, more agile, and faster. However, things are going to be becoming more complex, and we'll talk about how to manage that. So multi-cloud drives growth of complexity, and so what's occurred is that the number of on-premise systems and the number of cloud-based systems have, basically looking at the blue line here and the red line here, have in essence started to move up. So on-premise systems aren't necessarily going anywhere. We're typically not trading them off or moving into the cloud. Those are typically sticking around, or either redeploying them for another purpose, or they're just something that can't be outmoded, or they have to be paired with the public cloud-based processes. And cloud computing systems have just kind of have been booming. And so it's inflecting, as you see in the red line there, moving up to the right. And then if you look at the complexity metrics, we're just seeing a huge, immense rise in complexity as the number of legacy or on-premise systems really kind of goes to flat to very slow growth, doesn't necessarily go away. Number of cloud-based systems are inflecting, and therefore the complexity just kind of goes up because we're dealing with many different data points, more databases, more really kind of moving parts in these existing infrastructures. So we have to look at the cost angles as well. So multi-cloud drives increased cost. If you look at the cost of complexity, and basically as the cost of complexity goes up, costs go way up. We have to have people to maintain them. We have to maintain governance. We have to maintain security. We have to, in essence, keep 2 different skill sets around. We have to do cloud ops and existing on-premise ops with typically different tool sets and different skill sets going forward. And so ultimately, this is something that we're going to have to consider going forward, because, or else we're really going to just kind of take the value out of cloud computing. So if this goes unchecked, we start just basically moving things out into the cloud and leveraging hybrid and multi-cloud environments to do this. Typically, the on-premise systems aren't going away. We're going to drive the increased complexity. We have to have some mechanism or way to manage the cost, to manage the complexity. And this is all about thinking differently in how we're dealing with architectures. And if you think about it, if you kind of go back 20 years or so, architecture was really kind of a buzzword that everybody was dealing with, because we were building distributed systems, utilization of PCs. We saw the rise of the web at the time, and things were also going through another complexity curve. So we started to look at these different patterns of architecture, disciplined around how we configure these IT assets, and so they would be able to provide more value to the business. And what has happened is we typically abandon a lot of those existing disciplines and practices as we layered additional technology. We as enterprises kind of managed by magazine. We layered different PCs on top, client-server-based computing, the internet-based computing, service-oriented architecture, distributed web-based systems, and now really kind of cloud climbing on top. And so why we're moving in different directions to chase different opportunities with technology, we're kind of missing the point in the fact that we have to serve the needs of the business, and we have to arrange a IT architecture and IT infrastructure that's going to have those capabilities. So let's look at this stack. And so at the bottom of the stack, we have the cloud-based systems that we're leveraging. It could be AWS as a public cloud, Azure public cloud. Could be Google Cloud Platform. Could be Alibaba, which isn't up there. Or if you're leveraging a private cloud system, could be a private cloud or public cloud version of OpenStack. All of these cloud-based systems communicate as cloud services using APIs, or in essence, web services that exist within the clouds. We're able to invoke to access storage systems, to access compute systems, things that we want the clouds to do. And above this, we're looking at the concept of a cloud service broker or a cloud management platform to, in essence, abstract us away from the complexity of those APIs and services. So keep in mind that if we build a typical single cloud platform, say leveraging AWS, and we leverage the AWS services as well as the application services that are our stuff that exists in the cloud, we may have as many as 5,000, 6,000, 7,000 different API points that we're able to leverage to invoke either a cloud service that's native to AWS or an application server that's native to our applications. And going forward, that's just going to be too much complexity going forward. In fact, I'm kind of finding that the tipping point is 1,000. So once your enterprises reach 1,000 APIs, they're going to need some kind of a management mechanism to, in essence, abstract the complexity of those APIs from the cloud-based systems, from their applications, so they can be managed, governed, and secured. And that's really what we're talking about today, not necessarily doing different methodological disciplines in order to make these things work and play better together. This is about leveraging tools, technologies, approaches, different ways of thinking about how we're dealing with complexity. And going up, we have the storage consumer, the compute consumer, and the database consumer. All those things need to be addressed. We have people who are consuming information, such as an analytics program. We have legacy systems that are consuming information. We have people who are consuming storage, such as block and object storage, and compute, such as a raw platform, such as Linux, Windows NT, things like that. And of course, we have monitoring and management, the ability to kind of sit above these existing systems and monitor to make sure everything's working in an operational excellence kind of way. And so we're able to reboot servers, restart systems, things like that. We're able to capture monitoring metrics to see how things are performing and how we're kind of operating things on a daily basis. And by the way, all of this is systemic if you look on the left-hand side with security and identity management, services and governance, which allows us to, in essence, make sure that we're putting a blanket of security, identity access management, encryption, compliance services, everything that's needed based on what the industry you're in and based on the types of applications we're running, the types of data we're dealing with, to ensure that they're very secure. And if anything kind of jumps up with all these boxes, is the fact of the matter is that if you're going to run a cloud or run an IT infrastructure that includes cloud, you have all these various moving parts that you need to consider. And typically you're going to have additional things based on your industry, based on what you're doing. For example, IoT-based systems on a factory floor that are producing information that's being produced in the cloud. all of these levels of complexity that the enterprises are going through right now, and then looking for a better and kind of an obvious way or more repeatable way to manage these systems. So the business value needs to be defined as to why we're doing this. And so we need to understand the business metrics. We need to understand the costs, operational values, understand the agility values, and then we basically define success within the time period. Well, let's go over kind of each of these quickly. So understand the business metrics is really customized for your particular business. And so when I look at value models, the way in which I'm going to value a tire manufacturer in the Midwest versus a bank in New York City are going to be very different because they're very different businesses. So the way in which they value the use of technology and the strategic nature of technology is going to be basically a function of how they do their business and how how value comes back to the business in utilizing this different kind of technological stacks. Then next we need to understand the costs, really kind of how we look at cost base in these environments, and whether it's capital expenditures, operational expenditures, things like that, how we're going to break these things out, how we deal with costs, how we deal with budgetary constraints, all these things need to be considered. Then understand the operational values. And so, in other words, when we stick these things in operations, how do we, in essence, figure out how much value is going to come back from strict operational disciplines and strict operational toolings that it kind of comes into this? And so, are we going to be cost justified in creating an operational model, an operational tool chain that's going to span on-premise systems and public cloud-based systems and be able to run those things better than we could in the past? And if so, what value does that bring back to the business? Next, we need to understand the agility values, and this is a real key part. Why we used to look at operational cost savings as really the value of cloud computing and how we measure the value of cloud computing, say 20%, 30% ops cost savings once we migrated application workloads in the cloud versus the as-is state, which is the on-premise legacy systems, and the to-be state, which would be in a public cloud or hybrid cloud or multi-cloud environment. Ultimately, the real value of cloud computing is the ability to change IT quickly to accommodate the changing needs of the business, the changing needs of the market. In other words, we're able to keep up with the needs of the business in terms of how many changes we have to make per year to adjust to changes in the market or different market demands. And then ultimately how we're going to compress time to market. How quickly can we consume a business, buy a business, integrate their existing IT assets and make it work and play well with our cloud environment, allocate servers and resources we need to make the business run better. And you got to remember, it came from an environment, and I certainly worked in these environments as well, where we had to typically wait 6 months to a year to get hardware and software procured, up and running, tested, secured, and then installed within the data center. Well, now we have the cloud-based systems. We can do that in a matter of minutes. And that's kind of a game changer ultimately. And that's really where the impact or the value that this stuff is going to be brought back to the business. And then also define success within a time period. And so what is going to be our level of success? If it's going to be the migration of 1,000 applications out of the 5,000 we have in production right now, then how quickly can we do that? What value metrics are we going to use to measure success? And then ultimately, how are you going to be able to hit those value metrics going forward? And this is critical. This is where a lot of IT people make a mistake, because they make promises based on what they read, based on what they heard, based on what providers have told them, where ultimately this needs to be very carefully thought out in terms of how the value is going to be brought back into the business based on the risk, the expenditures that you're making and moving into the cloud. So you got the risk of cost overruns. You have to deal with initial expectations and how this happens. And so ultimately, if you've never migrated 1,000 applications, 1,000 workloads into the cloud, you're going to be running a lot of risk. You're going to be running a lot of risks of failure, making mistakes, going forward. And we need to set up initial expectations as to what this actually means. And this doesn't mean sandbag and try to increase the amount of time and budget you need to make these things happen. So anything that's going to be way below it will look good. This is about making a good faith estimate as to what's likely going to occur as we're making this move into the cloud, and understanding how the initial expectations need to be managed. Risk of missing the value. Budget and value need to be the same. Ultimately, how much money is going to be put out and how much value is going to come back, and also the metrics to measure value. So if this is agility focused, if this is time to market focused, or if this is ops savings focused, that needs to be defined ahead of time. And you need to be able to determine how the value is coming back into the business in a certain amount of time, and be able to prove that to the stakeholders within the organization to ensure that you're making a good investment with their money. And then the risk of missing agility. Cost too much to build, cost too much to run, missing business agility, missing strategic features. We're basically making the mistake of building something that's not necessarily going to be living up to the expectations of the agility part of it. And so in other words, we're for some reason making things very static in how we're running and architecting the applications. We're not using service-based systems. We're not using API-based systems. And therefore, as we move and have to change the applications, it's pretty much the same sort of hassle that we had to deal with when it was running on traditional legacy environments. And that's something that really won't go over very well, since that, in essence, is the value of cloud computing. And we're seeing people making the mistakes with that going forward. And keep in mind that if you have a very static and poorly architected system on-premise and you move it into the cloud, that doesn't necessarily make it non-static and non-poorly architected. You're going to have to change that system, remediate that system, refactor that system as it moves into the cloud so it meets those expectations. You need to understand those limitations ahead of time. And then the risk of rejection. Ultimately, if we move into our cloud-based systems, we're not doing a lot of things right. Performance isn't there. We're missing security features. It's too much of an impact on those who are, in essence, leveraging the system, the users of the system, the customers that we're looking to support with our cloud-based systems. And there could be amount of rejection that comes back from that, certain pushback, because we miss certain things as we're building these systems. So keep these things in mind. So the risk of cost overruns, typically going to be 80% likely. Risk of missing value, say 20% likely. The risk of missing agility, say 10% likely. And the risk of rejection should be 20% likely. And so risk of cost overruns is the biggest thing that I see out there that continues to be a problem going forward. We just don't have a realistic understanding of what the costs are, not only the migration costs, but the ops costs in terms of training, in terms of provisioning, in terms of over-provisioning, under-provisioning, in terms of managing users, all these sorts of things we have to change around the infrastructure. Risk of missing value, we typically are going to have a slight risk in that, but most people have a tendency to make the value that they set. And the risk of missing agility could be 10% likely. The great thing about cloud is really, if you move into cloud leveraging the best practices of leveraging cloud-based systems and moving your workloads into the cloud, typically agility is going to come along for the ride. And then the risk of rejection, you have 20% likely, because we're doing dumb things. We didn't consider communication performance. An application could be overly chatty and therefore doesn't perform very well, and it gets rejected by the users who are leveraging it. So keep in mind that we have to deal with clouds that cross countries, and this kind of takes complexity to another level. And so most corporations out there, the Global 2000, I deal with most of the time, are going to be multinational. And by being multinational, they're typically going to have a distributed application and distributed data infrastructure. And by the way, they may have to use different cloud services based on the countries that they're in. For example, Alibaba in China, and different kinds of points of presence in Europe, and different kind of points of presence in Australia versus the United States versus Canada. All these sorts of things really kind of come together in the fact that we're, in essence, backing our requirements into particular cloud platforms. They're going to be stronger in various countries going forward. So if you take a look at the stack we had earlier, the ability to, in essence, extend that to a public cloud service in one country versus another, and typically it could be as many as 3 or 4 different cloud providers based on the countries that you're in. You're going to have to figure out a strategy to deal with the complexity of managing the different cloud providers. Now, typically, this is going to be a multi-cloud problem, and so we really shouldn't have to worry too much about how we deal with multi-cloud in the same country versus how we deal with multi-cloud in multiple countries. But there's some additional things you have to consider. Number one, local laws and regulations in terms of compliance. For example, GDPR that just arose in Europe, and your ability to be compliant to those kinds of rules that are popping up. There's new privacy rules that are existing in China now. There's new privacy rules that are existing in Australia. All these things really have to be taken into account. And so typically, you're not only going to have a cloud management platform, a cloud brokering platform that's able to operate across countries, but the ability to, in essence, leverage a governance platform that's able to consider rules and regulations from multiple countries, as well as the industry that you're in. For example, in healthcare, in the United States, you have to deal with HIPAA. There's different rules and regulations you have to deal with Europe. So this becomes, another layer of complexity we have to deal with. And if you're a Global 2000 company, typically you're going to have multiple clouds that span multiple countries. So if you look at how we go ahead and make this thing happen and how we kind of normalize the complexity, we have to consider, we catalog cloud services such as storage, compute, databases. And so in other words, what storage systems we have in the different cloud providers, object storage and block storage, for example, Amazon versus Azure versus Google Cloud Storage. What do we have? What do we localize there within those systems? What about compute systems, EC2 on Amazon, different compute platforms in Azure and in GCP, Google Cloud Platform, as well as databases. We also could have special features such as machine learning or container-based development or container orchestration such as Kubernetes. And all these things really need to be cataloged and understood as we move to the next step. Next is cloud service location, where storage, compute, and database, what clouds are they located, what are they doing, how are they localized, not physically located, but in essence what regions are going to be in within the cloud providers, different kinds of meta design patterns we have in making those things work. And layered brokering management, basically abstracted services. This is where we get into what we're talking about in terms of the solution. So we have to think in terms of a layer of abstraction that exists on top of our storage, our compute, our services, our machine learning systems, our cloud-native APIs based on the cloud service that we're leveraging, or the application-oriented APIs are basically APIs that we own, and how we're going to make these things work and play well together. In essence, it's an orchestration layer that's able to deal with the resources at the meta layer, such as storage, compute, things like that, as well as down to the API layer. So we're doing this because we're able to combine things. And so we're dealing with storage as an abstract representation of storage. So whether it's implemented physically within Google Cloud Platform or Amazon Web Services really doesn't matter to us, because ultimately we're dealing with a single simplified version of how we're looking at these back-end resources and how we're looking at the applications. We'll talk more about that later. And we're able to produce services on demand, we're able to manage those services, and then we're able to consume those things by applications. And so the idea is that if an application owner comes to me, the operator, I'm going to leverage my cloud management platform and leverage my layer of abstraction to produce an abstract version of storage. Now, it may be implemented in Google Cloud Platform or maybe implemented in Azure, but that's really kind of hidden from them. And so instead of dealing with the complexity of all these various APIs, they're dealing with the abstraction layer, which is able to provision the kinds of resources they need and manage those resources through a single consistent API. So that's really kind of the idea behind it. In essence, we're trying to simplify things by combining things, by managing things as a single holistic unit versus trying to manage everything individually. And that's where we're going to kind of run out of gas. We're going to get beyond our tipping point. We're going to start making mistakes. We're going to start needing too many resources to make this happen, and then the value of cloud computing goes down the tubes. So a micro use case would be the ability to leverage a public cloud service that works best in specific countries. And so, in other words, if we're leveraging cloud computing within multiple countries, our ability to, in essence, leverage a cloud service that is going to be optimized for particular countries. For example, it has the GDPR compliance systems built into it. We can produce those services to people who need to consume them within those countries. So we consider the fact that, it's probably not a good fit for us to leverage a cloud service that's going to be sent across the ocean from an AWS instance in Ashburn, Virginia, but it is probably a good move to leverage a native cloud system that sits in Europe that has the ability to in essence, live up to the GDPR things because it's local. We're not dealing with data federation problems and all these sorts of things that really come into compliance. And so we're protecting ourselves from ourselves because we're putting governance layers on top of it that allow us to access the correct cloud resources to, in essence, make these things happen, or basically provide us with the optimal way to keep us out of trouble and provide the best performance and live up to the needs of the expectation of the person who's provisioning these systems. And the ability to divide databases between two clouds to deal with compliance data and data localization issues, that comes up all the time. We have certain data that can't leave on premise because of certain regulations or perhaps legal agreements. We have certain data that can't leave the country. And we have lots of data that actually can be hosted anywhere that we'd like. And our ability to federate those data, separate those data, and manage that data between two different systems to remain compliant and provide the performance that we need is going to be high on the list. The ability to create common security systems that span countries. This is a big one. We have a tendency to localize security within the countries where these clouds are being leveraged. And I think going forward, we're going to have to understand that security also needs to be abstracted. And so if we're dealing with multi-cloud systems that may exist in different countries, there certainly have to be some things that are going to be localized to the countries to where these things are going to be housed physically and logically, what regions they're in, but also a holistic security infrastructure which is able to keep track of these various resources. So identity access management, directory services, things like that span countries, and therefore eliminates a lot of the complexity in having to deal with multiple security domains and instances, which gets us in trouble because we have a tendency to lock things up and leave things open, not because we mean to, but just because the systems are so complex that the security operations people, the SecOps people, have a tendency to leave exposures occurring because it just becomes such a complex operation. Humans make mistakes, and we're trying to avoid that as much as possible. So in these use cases, we're seeing the ability to, in essence, adhere to this kind of model. So the clouds are, in essence, hidden behind the APIs, and we're getting hidden behind cloud service brokers or cloud management platforms. Now, to remember that cloud management platforms could be as many as 4 different tools, or as few as one. You shouldn't try to home bake this stuff. These are going to be very important systems that are should be maintained by outside folks, people that have cloud management capabilities, operational capabilities, cloud service broker capabilities, things like that. So when you evaluate that technology, you need to consider the clouds that need to be under management, private, public, legacy systems that need to be included, how you're managing the APIs, the types of cloud services you're looking to manage, but more importantly, the requirements that are coming down from the storage consumers, the compute consumers, and the database consumers. Now, what do they need, and how are you dealing with their requirements, and probably more importantly, how you're protecting them from themselves. And so we have the governance and security infrastructure in place so they're able to access the correct resource patterns, able to leverage the resources correctly during operations, and also able to secure the resources and govern the resources. And we're doing so through the simplicity of an interface where as we start adding and removing clouds and adding and removing workloads and data sets that exist within those clouds, we're not necessarily making things overly complex. And we're allowing it to scale in terms of complexity versus having to, in essence, stop, retool, move things in different directions, hire more people, train more people in different cloud-native systems versus looking at this as a single common interface, a single layer of abstraction. So the tech, as I mentioned, is a cloud management platform and cloud brokers. And by the way, they may be called other things, but there's many companies out there that make this technology, and your ability to leverage this technology effectively is your ability to look at your own requirements and then pick the best products out there and then test. And typically this is not going to be the normal 3 down to 2 down to 1. This is going to be the norm. This is going to be 10 down to 5 down to 2. And you're going to have to do a lot of research and a lot of testing to ensure that these things are able to live up to your expectations. The good news is that these systems will ultimately be on demand in many instances, so we're not having to, in essence, leverage software technology you have to bring in-house and load up and things like that, or even download. And so they're fairly easy to test and fairly easy to get in production for a testing cycle. Next, we need to deal with tech's policy-based cloud monitoring and management, the ability to, in essence, monitor and manage these multi-cloud environments, using the cloud service brokers if needed. So we're ensured we're not making mistakes in terms of how we're leveraging these various systems. Or we're putting limits on utilization of some APIs. We're watching for saturation of storage resources, saturation of database resources. We're looking to monitor who's using what, when, how much it's costing. We're looking at abstract metrics in terms of how we're dealing with performance information, security information, ability to have proactive-based systems to look at how the systems are behaving over time to deal with security-based solutions. All these sorts of things which we really have a tendency not to think about, not necessarily wanting to automate because we were used to doing these things in a manual way. But now we need to set up these policies to figure out what limitations we need to put on utilization of resources, link those into governance, and link those into security, and link those perhaps into your cloud management platform as well as your cloud service brokering platform to ensure everything is integrated one-to-one and that we're keeping track on pretty much utilization of the system by any resource or any machine or any human that's out there in the space that's leveraging these cloud computing systems. And it's extremely important that we do this because if you don't do this, you're going to end up finding what I call the hidden cost of cloud. And there's lots of folks out there that are getting $2 million cloud bills when they thought they were getting $1 million cloud bill per month that have overrides because certain things weren't taken into account in terms of people allocating additional storage and leveraging different cloud services without authorization, and them not necessarily knowing who did it, and the ability to kind of back it and charge it back to the people who are consuming it. And that's ultimately going to be something you don't want to do. And then attack identity access and access management and service resource governance need to be part of the play. So we all know that identity access management systems, the ability to, in essence, look at the identity of these various players, whether they're resources or humans or machines, and be able to grant or ungrant access to various systems based on who they are, is probably the best configuration, the best process, the best way to secure clouds. So look at that technology. So what's important is that public clouds are the building blocks of multi-clouds, and they'll make up 80% of multi-cloud solutions, and that's probably rising now, and so it could be 85, 90% by the time we're into 2020. There are a select few now, with Amazon, Google, and Microsoft being the most popular, and I anticipate that won't change as time goes on. Alibaba is going to be a relative player in the Asia-Pac market and probably increasing over time. But we're going to be dealing with 3 or 4 major cloud providers going forward, with a few out there that people are keeping an eye on. But ultimately, typically, this is where the market is. They provide very different features and functions, but they're very common patterns, such as compute and storage. And so, think about cloud computing. One of the things that's occurring is they're kind of commoditizing these various systems. And so, in other words, we're moving into storage systems that look a lot alike. We're moving into compute systems that look a lot alike. They're not exactly the same, but they have a tendency to they leverage each other's features and functions because it's popular in patterns. And if you think about good cloud computing systems are able to replicate infrastructure, storage, compute, networking, things like that, and do so in a very easy way. Time goes forward, they're improving on that infrastructure. And so typically what we're going to leverage within the public cloud-based systems is going to be better than we ever could leverage in the legacy environments. They all provide very different features and functions, but they're common patterns, such as compute and storage. I think I just mentioned that. So we have native cloud services, storage, compute, database security, DevOps, etc., and the APIs, and access to the public cloud resources. So keep in mind that native cloud services, or cloud native services as they're called out there, are going to be anything that's provided by the cloud provider that's going to allow access to any services that they have. And they're adding and removing these all the time, typically adding services. So if you look at Amazon and you look at Azure and you look at Google Cloud Platform, the services that they had a year ago are going to be very different than the services they have now. They're going to be updating, improving, and continuously improving these various systems. We have a couple of things. We can use them to build our applications. We can orchestrate them. We can combine them into processes, or we can observe them in production as we're leveraging these various systems through consoles. And of course, we have Cloud Ops, the ability to operate these systems. We have security operations, governance operations, DevOps, data operations, performance operations, and all other things such as machine learning-based systems and IoT-based systems, which are monitored and managed by humans as well as in automated processes kinds of ways. So we have the notion of Cloud Ops, which is something that has to be considered if we're going to deal with complexity. So we're dealing with Cloud Ops as a way to abstract ourselves away from the native cloud services, and dealing with SecOps, GovOps, DevOps, Data Ops, Performance Ops, and the other ops, IoT ops and things like that, through another layer of abstraction. So we're dealing with Cloud Ops. And as we're moving through the market and improving our best practices in terms of how we're operating clouds, we're finding that the tools and technologies that we're leveraging are doing exactly what we just talked about, the ability to kind of remove us from the complexity of the underlying system. So we have to do with data integration as well, the ability to, in essence, move information between the native cloud systems, Cloud A, Cloud B, could be AWS, Azure, Google Cloud Platform. And doing that, we need to transform the data, moving from one place to another, because typically they're going to be in different formats. They're going to be in different semantic structures. We have to deal with adapters as they're dealing with the various systems. We have to deal with application semantics, or how the data is represented from one application to another, and we actually have to move the physical data. And all these things, if they look very familiar, these are part of the EAI kind of constructs that are basically moving in the cloud. The fact of the matter is that we have to, if we're leveraging a multi-cloud system, abstract ourselves, again, away from the data integration practices. So we're leveraging tools and technology to deal with transformation, adapting to various systems, dealing with the differences in application semantics, and actually moving and transforming the data. So when we're dealing with multi-cloud, we're dealing with security, governance, data integration, operations, legacy, and lots of different tools that have to be part of the mix. And so if we're dealing with cloud complexity, you're going to need to have good answers for every one of these. We have to deal with security, governance, data integration, things that we already talked about, and certainly ops, but also legacy environments. And so we have to deal with our legacy systems, understanding that they're still going to need to work and play well with our multi-cloud environment, and as well as other tools in the mix, such as artificial intelligence tools, the ability to do container-based development, container orchestration, and whatever technology is going to come down the line has to have some sort of a place within this construct. So we need to deal with automation, tooling, and people. So automate as much as we can. We leverage the right tools and have the right training to train the people to make these things happen. So SecOps, GovOps, performance operations, app operations, data operations. I think we talked about previously with automating operations or cloud ops. Needs to be automated as much as possible. Leverage the right tools. And the big thing is train the people. I mean, this becomes a people problem as much as anything else. The fact that we're moving into a new paradigm, you have to basically have the technology, have the people trained up on how to leverage this stuff correctly. So we need to go through a couple of things, SecOps requirements, automation objectives, GovOps, basically requirements, automation objectives for each one of those. How are we going to automate security, governance, performance, apps, data, and the other aspects of our systems that may be localized to what we're looking to do. And in order to do that, you have to pick the right tools, look out in the marketplace, observe the tools, bring them in, test them, very much like we have to do with the other tools, such as cloud management platforms and cloud brokering systems and DevOps systems, configuration management, performance monitoring, All these things are really important, that we pick the right technology to make these things happen. So select the tools, and we continuously test the tools and continuously deploy the tools. Keep in mind that if you push something out that's a tool that has a tendency to not necessarily live up to expectations, that we're in a continuous improvement mode. And so it's okay to swap these things out as we're operationally moving through the cycles. And that's going to be part of the game. Continuously improving the system, continuously evaluating the technology out there, and then replacing the tool sets with better tool sets as they come along. There's no shame in that. And then monitoring and management, storage systems go down. For example, this is an automation system. If storage system down, then restart cloud-based storage server, check to see if back online, and then we log in alerts. We have these things in essence to make these systems self-healing. So it's not enough to really kind of put monitoring and management in place, but the ability to, in essence, put in logic to, in essence, have the thing fix itself as much as it possibly can before it alerts a human or before it logs the event, ultimately is going to be really where the rubber meets the road. So if we're going to continuously run these systems and we're getting to operational excellence, minor problems such as bad sectors on disks, things like that, can't bring your system down. You have to have the ability to recover from those things in an automated fashion. So software life cycles need to be automated. We have to deal with spec, code, build, test, deploy, and this really is kind of DevOps. So we're doing build automation and release automation, and we're continuously improving the various system. And this is also part of the complexity. And so if we're actually moving to reduce the complexity, we're trying to reduce the complexity of app dev test, security, and deployment as well. And by doing that, it's in essence moving into a DevOps kind of an infrastructure and automating as much of the life cycle as you can and automating as much as agile as you can. This is not a DevOps presentation, so I'm not going to go too much into it here, but understand that it's really kind of a core component to make cloud complexity management work. And with that, I'll kick it back to Ben.
Thank you, David. This was great. And we forgot to mention at the beginning, but it looks like some of you took advantage of this, that you can ask questions in the chat there. So if you think of any right now while we go through a few of these questions, please take advantage of that. So just starting off here, David, we have one question about you had the complexity graph. So how were you measuring complexity in those charts that you were showing?
Yeah, and complexity is really kind of a matter of looking at the number of API points or interface points that the applications have, how they're going to be managed, the number of those points, number of resources we're dealing with. For example, is it a single logical storage mechanism, or it could be multiple types of storage, such as block and object in different databases, and really throwing that into an algorithm that we've created just for the particular problem domain we're looking for, then coming up with a level of metrics that really kind of considers the number of systems. You notice that the number of cloud-based systems and the number of legacy systems, as those increase, so do complexity. And that's because we're typically binding those things to the number of systems. And so why we used to have, say 100, different systems in the legacy environment, if we fired up another 150 in the cloud environment, maybe there's still 75 remaining in the legacy environment, and therefore 150 that exist in the cloud environment. And that's obviously going to be more systems, more points of storage, and therefore the complexity goes up. How we measure that really kind of is dependent on the domain. And so you have to agree with the clients on what is measuring complexity in terms of how they're dealing with the difficulty in increasing the number of data points, points within the system that they have to manage. And that's what we did there. But pretty much it's really going to be a function of the number of systems, the number of APIs, the number of databases, resources that the systems leverage, really kind of as a raw measure of complexity.
That's great. That actually really helps explain that. Another great question came up here about data ops automation. So can you provide some examples of that, David? So data ops.
Absolutely. It's basically the old DBA job, but it's put into the cloud. And so we have the ability to, in essence, add, delete, remove, change database structures, change database tables, storage procedures, and triggers. You deal with BCDR of the database, in other words, how the database is backed up. and how it can be restored if something goes wrong, or even incremental restorations, how it's image stored, the ability to, in essence, deal with distributed databases, the deal with database mirroring. The list goes on. Basically anybody who's managed a database before, you're going to have 75% of the same tasks that exist within the cloud. But in the cloud-based systems, we have to deal with provisioning, we have to deal with monitoring of the cloud instances, we have to deal with costs because we're paying per drink and how we're leveraging the cloud. And all those things, in essence, kind of come together as a data ops sort of thing. So it's lots of very important things that have to happen in terms of operating those databases in the cloud.
No, that makes a lot of sense. So we have another question here. So it says, as you've outlined, there are many ops debts. But what do you think DevOps' focus should be?
I think DevOps should be focused in terms of cloud complexity and simplifying the ability to build, test, deploy, and operate applications as much as possible. So we have Agile and ability to kind of eliminate some of the fat out of building and deploying these various systems. If you bolt a DevOps process and a DevOps team and a DevOps tool set on top of what we're doing within the cloud, in essence, it should automate most of everything having to deal with development. So the developer should be able to code, should be able to hit a button and have it go through security testing, performance testing, regression testing, component testing, whatever automated testing procedures that you have. Any bends or kickback to him or her to fix, but then eventually it goes into deployment, goes into staging, goes into production with as little fanfare as possible. In other words, we should be able to do this on a hourly, daily, weekly basis based on the needs of the business. And the ability to kind of do that abstract us away from all these development complexities that we built in over the years, which really kind of is the essence of what DevOps does. That should be the objective. I think it's core to dealing with cloud complexity because it's core to building apps that are going to be easy to run and manage because we're removing some of the complexity in how we build it on things.
Okay, great answer. So, Dave, if you had to boil down a lot of these risks that you were talking about in terms of moving to the cloud, what do you think are the core risks that people should be thinking about?
I think the big risk is going to be expectations. It's the ability to kind of understand that the cloud is not a magic land, where there's unicorns and pixie dust and bunnies. It's ultimately a very hard platform to move to, and you have to understand the downsides and the upsides of making the move and be able to articulate that to the stakeholders in the organization and be able to go in there with both eyes open in terms of what we're having to deal with. And typically the platform is going to have a huge number of advantages over traditional systems. On-demand model, the ability to provision, auto-scale, and increase time and decrease time to market and increase agility, and all those things are really kind of true. But you have to understand what the hidden costs are, how these things are really going to come together in terms of a solution, and really kind of articulating that to the team, and also understanding the ops complexity of moving to the cloud, and the fact of the matter is that things are typically going to get much more complex first before they get easier to do.
All right. So when people are thinking through the cloud complexity management here, what's the best place to start? How do they start preparing? Where's kind of that first step?
I think the first step is to understand the underlying, architectures of cloud-based systems and how they would work and play well with a multi-cloud environment. I would focus on looking at the way cloud service brokers and cloud management platforms operate, and look at some of the cloud ops best practices that are starting to emerge, and really have a holistic understanding of what needs to occur in the day-to-day business of running clouds, and all the moving parts that have to work, and all the underlying details that have to occur, how you deal with security and governance, performance, all those sorts of things. And then ways in which we can simplify those things going forward, and how we can combine things, how we can deal with layers of abstraction, and how we can, in essence, remove us from the details which really get us bogged down in how these things work and play well together. So not necessarily having to understand every cloud-native API or every cloud-native resource, but understanding the abstraction of those resources and how they would be deployed in different cloud environments, but also from a single platform where we're going to, in essence, deploy those resources and drive it forward.
Okay. Now, one last question here. So, you had a lot of great information here, and if people want to find out more about cloud complexity or some of the other things you've done, where should they go?
Well, I blog on InfoWorld, and please check that out, as well as search cloud computing, as well as search AWS. But this is kind of a new kind of concept that people are approaching. I just noticed that Forbes wrote about it last week, and people are starting to pay attention to it. So look at take courses, my courses and other courses in lynda.com, but in essence, keep your ear down on the ground in terms of where this thing is moving to. And so if you don't have a good understanding of what cloud computing is, increase your understanding. Perhaps get certified in different cloud technologies and different management technologies and architectures and things like that. But this, in essence, is something that's emerging from a grassroots movement because the enterprises, quite frankly, are suffering today from this.
Yeah. Now, we actually had one last question here, and maybe we can keep this one a little short, but it's a great question, so I want to make sure to get it in. So, in migrating applications to the cloud, data privacy is a significant concern. In your opinion, is data privacy classification a prerequisite before moving data into the cloud?
Yeah, because you have to know what data we're moving and how to secure that data. And so some data is going to be HIPAA related or PII information. We got to classify it as such because we're going to secure that in a different way than we're going to secure customer information or perhaps innocuous operational information, things like that, because we're going to have to do different layers of encryption, different compliance of different systems. If we don't know and classifying the information that we're moving into the cloud, then we don't know how to secure it properly, and that's kind of fundamentally a mistake waiting to happen.
Yeah, absolutely. Okay, well, we're going to wrap up here. A couple housekeeping items before the last thing here. Everybody, you will be getting the audio and the slides here in a few days, 2 to 3 days. So definitely keep a lookout for those, and you will be able to access this later and share with other people. So thank you so much for coming on. And one thing that I wanted to share before we left you guys here is that Sumo Logic every year produces a modern applications report, and particularly this is key to what technologies are really becoming predominant in the cloud and how people are deploying applications and what's currently gaining steam and what the next technology you should be looking at. So you can take a look at this on our website. I mean, a couple of things that are really important here is that we've seen a huge growth in multi-cloud adoption and Azure deployments. So that's a big deal. AWS is still the big dog on the block, but it's an increasing adoption that we're seeing here. We're seeing changes in the cloud app stacks, like a huge increase in the amount of organizations using AWS Lambda, which is a serverless technology, using orchestration technologies, using Docker and Kubernetes. We're also seeing huge interest in security, which definitely relates to that last question. This is you're putting your customers' data, your key data into the cloud, and so keeping that secure is top of mind for organizations running in the cloud. And as part of that, we're seeing an emergence of this DevSecOps type of discipline where customers are taking things that they've learned from DevOps and from those kind of automation and applying that to security. So again, thank you everybody for taking the time to come to this webinar. You can actually find this report on Sumo Logic. If you should go to the front page, you'll see a banner at the top, and if you let the banner run, it'll be the second one you see, or you can go into our resources section. And we really appreciate your time. Thank you.